Get familiar with using this with some questions where you need to use more than one equation from the equation sheet. I call these multi-step calculations, and I'm going to show you how to do them. So how do you know if a question involves more than one equation? It's due to this thing here. They're either going to be 5 or 6 marks, and there's a lot of numbers in the question usually. So let's look at this example here then. So this is from the 2021 physics paper. So it involves a roller coaster. I'll show you the picture. We've got a car from the top of the track and it goes down, goes round a loop-de-loop and ends up at point D. And the question's asking what is going to be the maximum possible speed when it reaches position B. So position B is the bottom of the ramp. And it tells us that the height between A, the top, and position B is 90 centimeters. So the first one we're going to use is we're going to work out the gravitational potential energy using this equation here. So to work out gravitational potential energy, we need the mass times by G, gravitational field strength, times by the height, which we have already. Before we can use this, we need to put this in meters. So we divide by 100, which is going to give us 0.9 meters. So to work out gravitational potential energy, we're just multiplying those 4 things together, which is going to be equal to 0.3528. Now, the next thing is to look at an equation that gives us speed. Now, for paper 1, there's only one calculation that's got speed in it, and it's this one here, kinetic energy equation. So what we've got to say is that at the top of the ramp, the car has gravitational potential energy. And when it gets to the bottom, all of that is being converted to kinetic energy as it's moving along and it's not got any height anymore. So we can then say kinetic energy is going to be equal to what the gravitational potential energy was before, 0.3528 joules. And for kinetic energy, it equals to half mv speed squared. Kinetic energy 0.3528 is going to be equal to a half times by the mass, which is up here, times by the speed squared. So let's simplify this down a little bit. We can put the half of 0.02 onto this side. So we have 0.3528 divided by 0.02 gives us v squared. And we need to get v, not v squared. So we have to square root the whole thing just to get v by itself. If you put that all into a calculator, you should get the speed as being 4.2, which even though it's 5 marks, if you get used to doing these, they should be easy enough. You can get marks on them if you're willing to practice.